Hello, my name is Andrey, and I want to represent you my diploma project for the Advanced Data Science course from IBM. And my diploma project is connected with the prediction of the future rate of pair of currencies USD and Euro. And I worked with time series data. So time series is a sequence of values describing a process occurring in time, measured at successive points in time, usually at regular intervals. Time series analysis is a set of mathematical and statistical analysis methods designed to identify the structure of time series and to predict them. I used the CRISPR-DM methodology. This methodology has the following steps. The first one is business understanding, so we have to understand what business value and what we want to achieve resolving some business problem. The second one is data understanding, so we can have the huge set of data, and we should understand what data we have and how we can work with this data. The second step is data preparation. It's feature management. We can extract new features from the existed, or delete some features, or transform some feature to another type, and so on. The next step is modeling. On this step, we define our model, our algorithm, create different pipelines, and so on. The fifth step is evaluation. So we calculate our pipeline and we receive some values of our metrics. And the last step is deployment. If we achieve our goal and we receive very good results, so we can implement our model and our algorithm to some production environment. But if we don't have very good result, we should return to step number one and go through all these steps one more time. So my plan was to define the problem. The next one is feature management. Then the third step is make analysis number one and use linear regression, random forest, and cross-validation from on my dataset. Then the next step is analyze results of calculation. The fifth step is make analysis number two and to use neural network. The next step is analyze results from my neural network calculations, and the last step is total results, compare results from analysis number one and analysis number two, and make a decision whether I get very good result or not. So let's define the problem. We have a set of exchange rate values for a currency pair euro and used for a certain period of time, and based on the available data we should predict the rate for the next period of time. So on our graphic we have values for half a month, for example. So initially I thought about using the ARMA model. ARMA model summarized two simple time series models, the autoregression model and the moving average model. But I decided not to use it, and a little bit later I will show what I used. On this page we can see our initial data. So we have a data set with 7 columns. We have 2 columns about date and time, and also we have the columns with open rate, close rate, mean rate, maximum rate, and some information about volume. We don't need volume columns, and this column will be deleted from our data set. So, and we will work only with date column, time column, open column, min and max column. Close is also unneeded for us. So I didn't use ARMA model, but I used my own variant, the autocorrelation function with a shift. So we shift backwards the values of the open variable from first minute to 1437 minutes. It's a full day shift, and find the difference between the original values and after the shift. And in this case, we have 1436 new columns. And also make one shift forward for the target variable open and also find the difference. It's a column delta open. So you can see our new dataset below on the page. So for target variables max and min, I used moving average. So with the rolling window, we pass through the target variables and determine the max and min values for each window. And you can see the result of this action. Also, I tried to add additional feature. It's our feature because we have column time and we can extract hour feature from the time feature. And for the first dataset, I just add hour as it is. But for the second dataset, I transformed our value to categorical value, and it become it's now it have only two values, 0 and 1. So analysis number 1, and I define two algorithms: linear regression and random forest from the scikit-learn package, and also I used mean absolute error as loss function for my calculation. And mean absolute error, it's a sum of difference between original values and my predictions, and this sum divides on whole number of predictions that I got. Also, I used cross-validation. So cross-validation is used to estimate the loss function for the given model parameters, and it's always used to get a robustness model and to not to have overfitting of the model. So that's why I decided to see how it will work with my data set. So, and I used two variants of cross-validation. I used K-fold cross-validation from the scikit-learn library, and also I wrote my own function of cross-validation. So, and I wanted to compare these two algorithms. On this page we can see calculation results for open target variable, and we have three datasets: standard datasets without any transformation, and the second dataset has additional feature hour, and the third one has a categorical feature hour. So, and as you can see, random forest regressor works better than linear regression, and K-fold cross-validation and function give us the better result than random forest regressor. So here are the results for max target variable, and here results for min target variable. So since random forest regressor works better than linear regression, so let's plot the graphic for the predictions. And as you can see that prediction values are pretty far from the actual values, and I can say that random forest regressor doesn't work very well. That's why let's have a look at linear regression. And we can see that predictions are closer to actual values, but it's strange, but our values of max target variable are below than prediction values, and it seems that our model is not very good and linear regression doesn't work very well. So that's why I decided to try neural network, and I used LSTM because LSTMs are especially designed to avoid the problems of long-term dependency, and it works very well with time series data. And I used LSTM network from the Keras framework. And here the results of calculation of my neural network based on LSTM. So I used MSE, mean squared error, and RMSE metric, it's a root mean squared error, and RMSE metric is closer to mean absolute error because it's a root square of MSE, and we can compare RMSE metric with my metric as well, and we can see that our neural network give us worse result than random forest. But let's have a look on a graphic. So, and on the graphic we can see that our predictions more closer to actual values, and the most important thing is that the trend of our predictions is almost equal to the trend of actual values. Yes, of course, I didn't receive the specific rate that is totally equal to the actual values, but the prediction trend is good, and in this case we can work with the predictions value as well. So, what's the results of my work? If compared to algorithms, linear regression and random forest, so I can say that random forest regressor showed the best result. And if compare random forest algorithm and neural network, so the neural network showed worse result metrics, but the predictions were more accurate and we can pay attention on trend. And also I can say that maybe it's possible that we have the fact of overfitting of a random forest regressor. So in this case, a neural network is better. And but unfortunately, LSTM requires constant access to current data, and that's why for home use it's better to use either linear regression or random forest. And what I can do in the future with my models. Of course, the first one is make some neural network improvements, maybe add at least in one more time, or add some additional layers and so on. I can try MetaTrace library. I can try grid search for random forest regressor to receive better result, or try XGBoost, for example. And of course I can try to add new features to the dataset, maybe for example day of week, and it's maybe help me to achieve my goal. So that's all from my side. Thank you for your attention. If you have any question, you can write me email or by Skype. So bye bye.